All right. Advent of Code, day 11. Let's go. Okay, that was a bit slow, and that's exactly what I thought. Do do do. And this is going to be exponential growth, right? Because my answer was super big, yeah. And then let's just do, say, 35. Yeah, that's already completely bonkers. Okay, that's what I thought. So, um, and honestly, this feels like it should have a pretty distinct pattern also. Um, oh, that's gonna be interesting. Oh, that's gonna be really interesting. Um, yes. Um, uh, okay. Ooh, ooh, yeah. Game of one, you get that. These are not all even. They become. Ugh, okay. Oh, but these are independent. These are independent. These are independent. These are okay. Okay. That's part of it. These numbers get stupid. Did I type that right? I did. I used this one too long. Um, okay, so if we do um, in that case, that should give me the right answer if I did you right. You did, great. And if I go to 75, okay, bit slow. Bit slow to recognize that, but that's at least a decent performance for me. Okay. Um, yeah, I'm definitely more pleased with that than my last 2 days' performance. So let me just clean this up, make sure it still runs. Of course I need func tools. Now you, oh right. Uh, yeah. Got to rid of just a few too many helper functions. There we go. Okay, yeah. So, uh, part one is not too bad. We just have a couple of rules that we need to follow for each stone, for these stones in the input. Now, the interesting thing, and this comes into play in part two, is this is talking about the order being preserved. Yeah, this doesn't actually really matter one bit. The order of the stones doesn't come into play at all with these rules, and part two doesn't actually have any twist that cares about the order. So really, we can just treat each stone as its own individual thing. That's really the key insight and observation for part two. So yeah, we've got these simple rules where 0 becomes 1. If the length of the stone number is even, then we split it in two. And if neither of those apply, we just take the number and multiply by 2024. Pretty easy, and for part one, we can brute force this very easily. And that's what I did. I mean, we go over to the solution and just have this function that does the blinking, and I call it 25 times. I get the massive list of stones, get the length of that, and that's my answer. Part two, doing this 75 times isn't going to work. Like, just look at the size of that number. So that's when we need to take into account the observation that this says the order is preserved, but we don't care. As such, we can treat each stone individually. Since we can treat each stone individually, then we can memoize this. So this second count blink stones, it's really the same rules up as this first blink, where if it's 0, I do 1. If it's an even length string, I split it into 2. Otherwise, I multiply by 2024. But this is now memoized. So every time I see the number 2 with 6 blinks left, it's going to be the same answer. It really doesn't matter. So now we can just pretty efficiently calculate this. The one thing I am wondering, and I'm assuming that this is going to be explored in the Reddit, is there a deeper pattern here? It feels like there may be, and some of the math wizards on Reddit may find something where we don't even need to track the full numbers anymore, because some of these numbers are actually going to be pretty big. I would be interested to see what the biggest stone number is that we ever see. Because already right here we've got, what is this? That's a 10-digit number right there. So it feels to me like eventually if you blink too many times, even this is going to bog down unless you do trickier math. I'm sure we'll see pretty soon on the Reddit some people doing analysis of that. But yeah, overall, I'm definitely more pleased with my performance today than the last couple days. I wish I were a little faster to notice the memoization and dynamic programming approach for part 2, but still, rank, what was it, 130, 131? It's not too bad. I'll take that. So, yeah, definitely feeling better about that, and I'll be back tomorrow.